Now, in this lecture, we'll find out the area of a square. In the drawing, we have triangle ABC. Triangle ABC is a right triangle. Side AB of the right triangle ABC is equals to 5 units. Side BC equals to 12 units. This is angle ABC, that is a right angle. Inside this triangle, triangle ABC, we have square DEFG. And our mission is to find out the area of this square. Okay, so first of all, we find out the length of the hypotenuse AC of the right triangle ABC by implementing the Pythagoras theorem in this right triangle, triangle ABC. Here by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC. Therefore, the square of the hypotenuse is AC squared. So AC squared must be equal to AB squared plus BC squared. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. In conclusion, we found out that AC squared equals to 25 plus 144. 25 plus 144 is 169. So AC squared equals to 169. We'll take a root out of this equation, and finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13. So I write it down here. AC equals to 13 units in its length. We also have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. So side AC, line segment AC is one side of the right triangle ABC, therefore it is absolutely straight line. So if we focus on the lower side of the straight line AC here at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? Here we have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So the missing angle here must be equal to 90 degrees in its size. Likewise, if we focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore, the missing angle A must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line AC at point E to 180 degrees, here the missing angle must be equal to 90 degrees. Okay, so in the next step, we define this angle, that is to say angle ACB, as alpha, and we focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees, that is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, and therefore the missing angle here must be equal to beta. Here we have the equation that 90 degrees minus alpha equals to beta. We'll add to this equation alpha, and then we subtract beta, and we get that 90 degrees minus beta equals to alpha. We focus on this right triangle, the small right triangle, triangle ADF. The small right triangle, triangle ADF. This angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle here equals to alpha. Likewise, we focus on this right triangle, triangle EGC. And in the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta here, and therefore the missing angle here equals to beta. So line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G? We have this angle that is beta, plus this angle that is 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on one side of a straight line. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha here. So the missing angle here equals to alpha. In the next step, we'll focus on this small right triangle, triangle FBG. In the small right triangle, triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta here. Therefore, the missing angle here equals to beta. So, we have in the drawing in total 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. In all those 4 right triangles, we have the same 3 angles, alpha, beta, and 90 degrees. Therefore, all those 4 right triangles are similar to each other according to angle, similarity rule. I repeat again, all the 4 right triangles that we have in our drawing are similar to each other according to angle, similarity rule. So for example, we have this is the right small triangle FBG that is similar to the right big triangle, triangle ABC. So I write it down. The right big triangle ABC is similar. This is the sign of similar to the right small triangle, triangle FBG, according to angle similarity rule. And for the fact that the big right triangle ABC is similar to the small right triangle FBG, we will derive that the following relationship exists between their sides. We will derive that side, but before that, we will define the length of this side BG of the right triangle FBG as x. So what will be the length of this line segment GC? From the drawing it is very easy to see that the GC equals to BC minus GC. Again, CB minus GB equals to GC. CB is 12, GB is x, therefore in total CG equals to 12 minus x. Again, the length of line segment CG is 12 minus x. In the next step, we define the length of one side of this square DEFGSL. EG equals to L according to our definition, and therefore all the other three sides must be also equal to L units in their lengths, because of the fact that in any square all the sides are equal to each other. So DE must be also equal to L, DF equals to L, and FG is also equals to L. And from the fact that the right triangle ABC, the right big triangle ABC is similar to this right small triangle FBG, we derive that the following relationship exists between their sides. We will derive that side FG over side BG in the right triangle FBG, FG over BG is equals to side AC over side BC in the right big triangle, triangle ABC. Side AC over side BC in the right triangle, triangle ABC. Repeat again. From the fact that the right big triangle ABC is similar to the right small triangle, triangle FBG, we will derive that FG over BG in the right triangle FBG equals to AC over BC in the right triangle, triangle ABC. Okay. So here FG equals to L according to our definition, and BG equals to X also according to our definition, and it is equals to AC, that is 13, the length of the hypotenuse AC of the right triangle ABC is 13, over BC. BC is 12 according to what is given us in the question. So actually, according to equation 1, I found out that L over X equals to 13 over 12. So here we will multiply this equation, we cross multiply this equation, equation 1, and we get that 13x equals to 12L Here we'll divide this equation 1 by 13, and finally we'll get that L according to equation 1, x equals to 12L over 13. Okay, according to equation 1, x equals to 12L over 13. We actually know that the right big triangle ABC, is similar to this right triangle AGC. So I write it down. The right big triangle ABC, is similar to this right triangle AGC. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that EG over GC in the right triangle EGC equals to AB over AC in the right triangle EGC, in the right triangle ABC. Repeat again. From the fact that the right triangle ABC is similar to the right triangle EGC, we derive that EG over GC equals to AB over AC. So EG equals to L over GC. GC equals to 12 minus X, and it is equals to AB. AB is 5 over AC. AC is 13. So in conclusion, found out that according to equation 2, L over 12 minus X equals to 5 over 13. So here we'll cross multiply this equation 2, and we get that according to equation 2, 13L equals to 5 times 12 minus X. So here we'll open the brackets on this side of this equation 2, and we get that according to this equation 2, 13L equals to 5 times 12 is 60 minus 5x. Here we add 5x to this equation 2, and we get that 5x plus 13L equals to 60. Here we subtract 30L from this equation 2, and we get that according to equation 2, five x equals to 60 minus 13L. Repeat again. According to equation 2, we found out actually that 5x equals to 60 minus 13L. So we can substitute x in this equation 2, by the value for x that we already found out in this equation 1. So we substitute x in this equation 2 by 12L over 13 that we found for the value of x in this equation 1. We'll do it now, and we get that according to this equation 2, it is 5 times x, and x according to equation 1 is 12L over 13. That is equals to 60 minus 13L. Here we have 5 times 12L is 60L over 13 equals to 60 minus 13L. Here we'll multiply this equation 2 by 13. And we get that according to equation 2, 60L equals to 60 times 13 is 780, and 13 times minus 14L is 169L. If we found out that according to equation 2, 60L equals to 780 minus 169L. Here we'll add to this equation, equation 2, 169L. And you get that according to equation 2, you have 60L plus 169L is 229L, and 229L equals to 780. So here we divide this equation 2 by 229, and we get that according to this equation 2, L equals to 780 over 229, and 780 over 229 equals to 3.40611 units. So L, this is the length of one side of this square ABCD, and square DEFG. L equals to 3.40611 units. And we know that the area of square DEFG is equals to this one side of the square squared, and one side of the square is L, so it is L squared. So L squared, just I now found out that L equals to 3.40611, and L squared is 3.40611 squared, and 3.40611 squared is equals to 11.6016 square units. In conclusion, we found out that the area of square DEFG is equals to 11.6016 square units. And that is the answer to the question. Repeat again. The area of this square DEFG is equals to 11.6016 square units. So we finished with the question. In the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEFG. So in the drawing, we have a right triangle. Triangle ABC is a right triangle. And inside this right triangle ABC, we have this square DEFG. And we have to find out the area of this square. In addition, we know that side AB of the right triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. And this is angle ABC, that is a right angle, it is equal to 90 degrees in its size. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again. In the right triangle ABC, according to the Pythagoras theorem, AC square must be equal to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC equals to 12 units, therefore BC square is 12 square, that is 144. In conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 equals to 169. In conclusion, we found out that AC square equals to 169. We took a root out of this equation and finally found out that AC equals to 13 units in its length. That is to say, the length of this hypotenuse AC is equal to 13 units. In the next step, I presented to you rule 2. According to rule 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so we have AC is one side of this right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point D here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is a right angle plus this missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees in its size. Likewise, if we focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is right angle plus this missing angle. In total must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees in its size. So in the next step we focus on this right triangle ABC, triangle AFD. In the right small triangle AFD. In the right triangle AFD. But before that, we define this angle as alpha. So in the right big triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, and therefore the missing angle here equals to beta. Okay? And here we have 90 degrees minus alpha equals to beta. If we add to this equation alpha and then subtract beta, we get that 90 degrees minus beta equals to alpha. Okay, so in the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. Likewise, in the right triangle EGC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. but 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. Okay, then we focus line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of this straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G, we have this angle that is beta, plus this angle that is equal to 90 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus beta, but 90 degrees minus beta equals to alpha, so the missing angle here equals to alpha. In the right triangle FBG, in this right triangle FBG, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. So in our drawing, we have in total 4 right triangles. 1, 2, 3, and the right big triangle, triangle ABC. On those all 4 right triangles, we have the same 3 angles, alpha, beta, and 90 degrees. Therefore, all those 4 right angles are similar to each other according to angle similarity rule. I repeat again, all the 4 right angles in the drawing are similar to each other according to angle similarity rule, because they have all of them have the same 3 angles, alpha, beta, and 90 degrees. Okay. So, for example, the big right triangle ABC is similar to this small right triangle, triangle FBG. Okay, again, the big right triangle ABC is similar to the right small triangle, triangle FBG. And for the fact that the small right triangle FBG is similar to the big right triangle ABC, we derive that the following relationship exists between their sides. We derive, but before that, we defined side BG of this right triangle FBG is x, so BG equals to x, and therefore GC equals to CB minus GB. Again, CG equals to CB, that is 12, minus GB, that is x. So total CG equals to 12 minus x. Then we defined the length of one side of this square as L. So if BG equals to L, then GE also equals to L, DE also equals to L, and DF also equals to L. Why? Because of the fact that all the sides of any square are equal to each other. So, because of the fact that the right big triangle ABC is similar to the right small triangle, triangle FBG, the following relationship exists between their sides. Side FG over side BG in the right small triangle FBG equals to side AC over side BC in the right big triangle, triangle ABC. Repeat again, because of the fact that the right big triangle ABC is similar to the right small triangle, triangle FBG, we derive from that FG over BG in the right triangle FBG equals to AC over BC in the right big triangle, triangle ABC. FG is L, BG is X, AC is 13, and BC is 12. In conclusion, found out that according to equation 1, L over X equals to 13 over 12. Here we cross multiply this equation, equation 1, and found out actually that 12L equals to 13L, 12L equals to 13X, 12L equals to 13X. Here we divided this equation, equation 1 by 13, and finally found out that X equals to 12L over 13. Again, according to equation 1, X equals to 12L over 13. Likewise, the big right triangle ABC is similar to this right triangle, triangle GC. Okay, again, the big right triangle ABC is similar to the right triangle, triangle AGC. From the fact that the right triangle ABC is similar to the right triangle EGC, we derive that the following relationship exists between their sides. We will derive that EG over GC in the right triangle ABC equals to AB over AC in the right triangle ABC. I repeat again. We will derive that EG over GC in the right triangle EGC equals to AB over AC in the right big triangle ABC. EG is L, GC is 12 minus X, AB is 5, and AC is 13. In conclusion, found out that according to equation 2, L over 12 over X, L over 12 minus X equals to 5 over 13. Here we cross multiply this equation and equation 2, and finally found out that 13L equals to 5 times 12 minus X. So 13L equals to, here we open the brackets on this side of the equation and found out that 5 times 12 is 16, 5 times minus x is minus 5x. In conclusion, found out that according to equation 2, 13L equals to 60 minus 5x. Here we added 5x to this equation 2, and finally found out that 5x plus 13L equals to 60. Here we subtracted 13L from this equation 2, and finally found out that according to equation 2, 5x equals to 60 minus 13L. Here we divided this equation 2 by 5, and finally, but before that, we substitute x in this equation 2 by the value of x that we found in equation 1. According to equation 1, x equals to 12L over 13, therefore we can substitute x in equation 2 by 12L over 13. We did it and we got 5x equals to 5 times 12L over 13, and it is equals to 60 minus 13L. So 5 times 12L is 60L, so in total this expression equals to 60L over 13. 60L over 13 equals to 60 minus 13L. Here we multiply this equation 2 by 13, and finally found out actually that 60L equals to 13 times 60 is 780, and 13 minus 13L equals to minus 169L. Here we added to this equation 2 169L, and finally found out that 60L plus 169L equals to 229L, and so 229L equals to 780 according to this equation 2. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229. And 780 over 229 is 3.40611 units. So, in conclusion, found out that the length of one side of this square DEFG that equals to L is actually 3.40611 units. And we know that the area of any square is equals to the length of one side squared. The length of one side is L, therefore the length of one side square is L squared. L is equals to 3.40611, therefore L squared equals to 3.40611 squared, and 3.40611 squared equals to 11.6016 square units. In conclusion, found out that the area of this square DEFG equals to 11.6016 square units. Okay, thank you very much.